So one of the last topics that we'll talk about in this unit is about just other air pollutants, for example, acid rain. But there's tons of things released in the air, so we'll talk about a couple different topics, but moving away from climate change and moving away from carbon dioxide. So acid rain you've probably learned about for quite a while now, and we'll get into a little bit more specifics that maybe you didn't know when growing up. So acid rain, or I guess more scientifically, acid deposition, doesn't just mean rain. Acid deposition is used to refer to rain, as well as snow, fog, dust. Really any kind of precipitation can be acidic and can have effects on the ecosystem. Because I always learned about acid rain growing up, that's probably what I'll refer to it the most in this lecture. But just know that it's not just rain, that other forms of precipitation, even things like dust and sand, can also have acids and make a lot of the same effects that we're going to talk about when talking about acid rain. Acid rain is caused by two gases that we release into the atmosphere. Those two gases are sulfur dioxide and nitrogen dioxide. So we've got sulfur, so one sulfur, and dioxide, meaning two oxygens, and nitrogen dioxide. Don't worry, for the most part, there's not really that many equations as compared to ocean acidification. Now, regular rainwater, just good old rain, not acid rain, has a pH of 5.7. This is an acid. Remember, acids are those that have a pH less than 7. The reason that regular rainwater is slightly acidic is due to carbonic acid. In the air that you and I are breathing, we have carbon dioxide. Rain is H2O. As we learned with ocean acidification, this makes H2CO3, which is carbonic acid. So our rainwater has carbonic acid in it. It's not a strong acid. This is like it's raining coffee. This isn't going to kill you or burn you or anything like that. Acid rain, however, is rain that has a pH of less than 5.7. So it is more acidic than our typical rain. Some acid rain has been so low as low as 2.4. Like that's getting to the battery acid level of pH. But it's not. I mean, this is still kind of like lemon juice, something that might sting a little bit if it got on your skin. So acid rain is pretty acidic water. Now the way it works, again, very, very light chemical equations, is with our two gases, they mix with water. So you've got this sulfur dioxide plus water, and it makes H2CO or SO4, sulfuric acid. This kind of looks similar to our carbonic acid. I know there's an extra oxygen here. There's a reason for that we won't talk about. Just know that sulfur dioxide makes sulfuric acid. Nitrogen dioxide, when added with water, makes nitric acid. These acids are stronger than carbonic acid. So although carbonic acid will make things acidic, sulfuric acid and nitric acid have lower pHs, and therefore will make things more acidic. So where are these gases coming from? They actually come from two different places. Sulfuric acid is really common in volcanoes. There is actually a lake underneath this volcano, kind of like in the pool of the volcano. It has a pH of 0. It has the lowest pH ever because there's so much sulfur dioxide around volcanoes. In swamps will also release a lot of sulfur dioxide. That's done by our anaerobic bacteria. We talked about anaerobic bacteria earlier, that they release methane, and there's some of them that will release this sulfur. Also, lightning is a huge source of energy. In our atmosphere, we have tons of nitrogen and we have tons of oxygen. When lightning strikes, so I'm just going to draw this, when lightning strikes, that's so much energy that they will push those molecules together, making this NO2. So for swamps and for volcanic activity, this is where we can find naturally occurring sulfur, And with our nitrogen dioxide, we mainly get that through lightning. But this wouldn't be an environmental biology course if I didn't talk about humans' influence on this. When it comes to sulfur, of all sulfur dioxide emissions, this includes swamps, this includes volcanoes, 70% of all sulfur dioxide comes from us, and specifically comes from coal-powered plants. Coal has a bunch of sulfur in it. It just naturally occurs with coal compounds. So when we burn coal, not only are we releasing carbon dioxide, but we also release some sulfur dioxide. With nitrogen dioxide, 55%, so again, taking account all the different emissions of nitrogen dioxide, 55% comes from our vehicles and other transportation. So not just cars, but things like jet fuel for airplanes or fuel for trains. Any kind of gasoline is going to release quite a bit of nitrogen dioxide. So I mentioned those natural sources because they do exist and they do give off these gases. But we as humans, we give off more, which is why I want to bring attention to it. So this is happening around the world. I'll focus on the United States though. This isn't a problem everywhere. Here in green, these are pHs that we would expect for regular rainwater. And you see out here in the West, we really don't have that much acid rain. What we do see is here on the East Coast, and particularly in the New England area. We're having rain in the 4.4, 4.3 region, so quite acidic. The reason it's happening here is think about our industry. Think about our population. A lot of the human population lives over here. They live in New York City. They live in like the entire state of New Jersey. They live in Washington, D.C. They live in Philadelphia. They live in Boston. You have all these really, really huge cities with a lot of transportation that is contributing to nitrous oxide. You also have because you have a lot of cities and a lot of people, you also have a lot of coal-powered plants. You also have a lot of industry. And so we can actually see that evidence just by looking at acid rain as to where are the major polluters in the United States. But you may think, well, there's a lot of population, down here in California. California's lucky. Wind kind of blows this way for California and will actually kind of blow their acid rain out into the water. For us, we're not as lucky. It kind of stays over us. So what does it actually do though? Yes, it's acidic, but it's not melt your skin off acidic, so why do we care? One thing that can happen in our ecosystem is that acidic rainwater eventually will enter a water body. It'll enter a lake, it'll enter a pond, it'll enter a stream, and the organisms living in that environment sometimes can't handle it. For example, fish. As an adult, the fish would probably be fine. However, if you look at their eggs, when they lay those eggs, that acid can affect the growth of those eggs and make it so that those eggs never hatch in the first place. So for example, here we have, let's look at, say, clams. Clams can exist in a pH of 6.5, they can exist in a pH of 6, but when it comes to a pH of 5.5, they can't survive. Even regular rain is about a 5.7. So clams can't reproduce and live. Snails can't reproduce and live. We do get lucky though, in the sense that if you look at frogs, frogs are fine. Frogs can live at 6.5, at 6, 5.5, 5, 4.5, 4, and be just fine. But although frogs can be just fine, frogs of all these species are the most tolerant, that doesn't mean what they eat are tolerant as well. For example, frogs eat tons of mayflies. Mayflies don't really exist in water less than 5.5. So let's say we're in one of those acidic streams. That acidic stream prevents the mayfly from reproducing. The frog is just fine, but it doesn't matter because that frog eats the mayflies and there's no mayflies around, so the frogs won't be around either. Now you might not care about these animals, but it cascades. there's animals we do eat from these rivers, and these animals are kind of important in their own right. Not only can acid rain affect aquatic environments, it can also affect the terrestrial environment, or our land environment. Acid rain, acid snow, acid fog can really weaken organisms, particularly plants. Sometimes the plants can recover and they're totally fine. But if you imagine a forest that's always in acid fog, that fog that's acidic is going to break these plants down, and those plants never get a chance to recover. This is actually a huge problem in the Adirondack Mountains, which is what you see here, that's in the New England area. About a fourth of all their ponds have pHs less than 5, and you see tons of forests like this, ghostly white, full of dead trees, because the trees just could not handle the acidity that they were always in. These trees we really can't even use because they're rotting. We can't even harvest them to use them for anything. So there's an example of how humans are losing out on biodiversity in our environments.